Okay, welcome to the demo. I'll just first show a demo of all the features, then I'll just explain the system simply with the system design. This is being propagated. This is the main agent where like the DB, I'm just propagating it with some dummy data for now. So it will take a bit to load at the start. And here we'll have the demo UI. This will be the UI for hospitals to upload the structured and unstructured data. So I'll just show the agent feature slowly. So let's just ask it, hello. I used LangGraph with Gemini for this one. And so it can track resources in real time from the DB it has been connected to. Then it can give regional summaries of data in the specific regions as per the DP. It can find alerts. It can predict the shortages and it can give allocation strategies. So let's see the dashboard and I'll show you the database that is stored. Okay. So we for now I've made a simple one where just ventilators, oxygen, and ICU beds are stored with their quantities, and the status is marked by layer one of the prediction system. The layer one is ARIMA based, which is the autoregressive model for time series data. So with it, whether it is in a critical state or not is marked. That is the layer one. And for prediction, layer 2 is the LLM, which explains why it has been marked as such. Okay, this is the DB. These are the alerts. And I'll first ask it for, and I can run AI prediction analysis from here or from here as well. So for now, I'll just ask it, show me all the hospitals you are handling. Okay, so give me inventory of year one. Confirm. Okay, so these are what it has. Now let's say I'll try to add ICU beds from here. So this will be how the hospital submit for structured and unstructured data. So now this is the structured data part. Let's say I add, this is Yeroda, right? Yeroda Civil Hospital, Yeroda Civil Hospital. Okay, before that I'll just add some ICU beds. Okay, so this is the structured data. Check again. I've configured memory with LangGraph's SQLite integration, and that stores the conversation's last 10 messages, I'm pretty sure. Okay. And the issue beds are updated in the DB for like the REST APIs are set up for this inventory snapshot. And for this will be the unstructured data. For unstructured data, I thought it will generally be news articles where an LLM and like the system is such that the LLM processes them from the news article, finds the summary for what may be an alert from it, then and some extra info, severity, etc. Then it is pushed onto Chroma DB in vector embedding format. And whenever some query needs the alerts or alerts are directly asked, then give me the alerts in city. So when something like this is asked, it will mm, it will use semantic search to find the alerts. Like for now, these are the dummy alerts that have been stored. Okay, now these are the alerts. Now let's see the next feature, which is uh, shortest prediction. So predict upcoming shortages. Let's see. Mhm. Okay. So, so because there are all zero marked, it suggests that there's a data anomaly. That is why it has a low confidence because so many with zero aspect ventilators may be weird. But still, it has marked these because they have zero available and it has marked these as critical from there. So based on that, it has marked these as shortages because they are shortages, and from the dashboard we can see that others aren't really at a shortest prediction point. Like for the prediction part, it is not just the decrease that is used, it is also like how in the data how much they were getting increased by. So like there this was calculated, which was net daily change. So from the net daily change, it was calculated to see the shortage. Now let's say I want to fix the situation in WACD, I can ask it for allocation strategy. Give me allocation strategy to fix the situation. WACD. Okay. Now the hospitals are also stored the latitude longitude in the actual DB. So from it, it calculates the distance, it gives the distance to the models. And yeah, so risk averse is just to prevent the immediate risk. Cost optimized is to just make it fixed, but at a lower cost as possible. And for it, I just give it a bunch of context like the distance data and availability. Like only the hospitals in surplus are able to transfer, and that is why these are different. So now that we have multiple options, recommended actions, one thing I could have done is maybe when I accept something, it could connect to the email stored in the hospitals to go there, but I haven't set that up. So let's say I want to accept the cost optimized one in general. So now I'll get to the RL part. For RL, I'm saving seven dimensions basically. Three are just direct scores, which is cost, speed, equity for the strategy, and quality, risk tolerance, feasibility, impact, priority, sustainability. These are just updated using like based on what I accept, what I reject, and these are given to the LLM during its strategy allocation so that it gives more of the strategies that I prefer as it goes on. Like these are currently like slowly updated. Like this was 33, this became 34, and so on. Like it does not update very fast. But yeah, so these were what I thought I could do for the RL part. And those are pretty much the features. Next would be like the scenario simulator is just I choose two hospitals and try to send resource time and just gives what the simulation would be. Honestly, this is not very useful right now. I just thought it could be useful. And data ingestion, this is just for the dummy data insertion for more testing. Okay, that's it.